let's go ahead and try to solve question number 4 to 7. So this is a here the transfer function of a system is given as gs. Okay, gs is 10 upon s into s plus 5. The system is placed in a unity gain feedback as shown in figure 1. So same unity gain feedback is given, and the system is gs 10 upon s into s plus 5. Calculate the gain crossover frequency of the system shown in figure 1. Right. Now tell me one thing, what will be the phase crossover frequency for this kind of question? Think about it. See, okay, so it is a two pole system, right? It's
Ma'am,
supposed.
zero.
No, I'm asking.
No, no,
हाँ,
ma'am.
बोलो.
Phase crossover frequency.
Hmm. See, the system has only two poles, right? So, agar if a system only has two poles, that means the phase will maximum the phase will go is of minus 180 degree, and that will also be at infinity. So the phase will be something like this, right? So this point is minus 180 degree. It will be asymptote, and at infinity the phase will become minus 180 degree. Okay, so here the phase crossover frequency will be infinity. Why? Because the system will never, the phase of the system will never cross minus 180 degrees. That is because the system only has two poles, right? If the system has more than two poles, then it would have crossed minus 180 degree. So this system will always be stable. It's a
Yes,
stable.
ma'am.
Okay. Any doubt here?
No.
Okay. So now let's try to solve the gain crossover frequency. So the gain crossover frequency basically means that when the gain will be less than unity, right? That frequency will be known as gain crossover frequency. What does gain crossover means? That the when the gain crosses 1, this is 1. When the gain crosses the value 1, then at that frequency it is known as gain crossover frequency. So you have to find out here, you have to find out gain crossover frequency in such a way that gain crossover frequency you have to find out. So here you have to find out the frequency in such a way that the gain becomes below 1. The when at exactly that point where gain becomes 1, that frequency you have to find out. Got it?
Yes, ma'am.
Okay, now try to solve this question and then we'll discuss about it. I'm giving you 5 minutes. क्या?
Ma'am, 1.87.
Okay. Okay, very good, Shubham. So let's try. Sorry. So let's try for some more time. Let's see if others also join and try to solve this question, and then we'll solve it. Okay. We'll discuss about this question.
Okay. Ma'am,
Yes, go ahead.
ma'am, one question. In the exam, which type of questions will be asked? Means MCQ type, or we have to write something, or
Okay, so I am still not familiar with the format of the exam, but
okay,
as
ma'am.
per my experience, it will be MCQ type. But I am not saying this with 100% surety since I'm not familiar with the format of the exam. But
Okay, ma'am.
yeah, most probably it will be MCQ type. Okay, chalo. So let's try to
Okay.
solve this question now. So gain profit. So what you said 1.87. Let's see if 1.87 is the correct answer or not. Yes, good. So Shubham, that's a correct answer. So 1.87 is the correct answer. Now let's try to solve it. So as I said, at omega is equals to omega g, gain gs. It should be something like gain g h is equals to 1, right? Now since the feedback is already 1, right, mod of gs will be equals to 1. So from here we will find the value of omega, right, and that omega will be the value of gain crossover frequency. That is, we'll put yes. So this is from here. You got the concept behind it, right? So you have to equate mod of gs is equals to 1 to the magnitude of this, right? So we got something like this, and then we solved it using simple arithmetic calculations are there, and we'll get omega g equals to 1.87 radian per second. This is the correct answer. Okay, got it right. Any doubt?
No.
Okay, chalo, let's go ahead and try to solve question number 5. So here you have to find out. Now you have already got gain crossover frequency, right? Now for this gain crossover frequency, you have to find out the phase margin. Okay, you already know the how to calculate phase margin. That is 180 degree, right? 180 degree plus the phase, and this phase will be at the gain crossover frequency. So at the frequency where gain becomes 1, at that frequency, whatever the phase of the system is, plus 180 degree will be equals to phase margin. Okay. So first what we have to do here is we have to find out the phase of the system where mod of g is equals to 1. So at the gain of the system becomes 1, there will be a frequency which is known as omega p. For that value we have to find out the phase, and then add it with 180 degree, and we'll get the phase margin. Now try to solve this question. I'm giving you 3 minutes, and then we'll discuss.
Ma'am, option C.
Option C.
C, C.
Okay, okay. So I'm still giving others to solve this question, and then we'll solve it.
Ma'am, what is the meaning of phase margin?
So phase margin is like gain margin, right? Phase margin also suggests the margin in phase as that the gain is, before that the gain is above 1, and after that the gain becomes below 1, right? Okay, I have one. Okay, so here also, see, the greater the phase margin, the greater will be the stability of the system. Similar to the greater the gain margin, the greater will be the stability of system. All right. So the phase margin refers to the amount of phase which can be increased or decreased without making the system unstable. So after this phase margin, the system becomes unstable. It is usually expressed as phase in degrees. Okay. So we can generally with the use of Bode plot, we can find out the value of phase margin. Okay.
Here it is written that the greater the phase margin, the greater will be the stability.
Yes.
Uh, but the phase margin should be 45 degree to 180 degree for the design of
No, no.
anything.
See, so generally the phase of the system is in negative, right?
Yes, ma'am.
So the if the phase of the system is like small, then it means that the phase margin will be greater, right? And if the phase margin will be greater, that means, see, if the if the uh, uh, okay, let's say the phase of the system is below minus 180 degrees. So that means the phase of the system will become, let's say the phase of the system is 190 degree, right? So this makes the phase margin negative, that is minus 10, right? This means that the our stability of the system is very low. Here the system is unstable. Okay, the system is unstable, but let's say that the phase of the system is 45 degrees, right? That means the phase margin will be how much? 180 minus 180 minus 45, which is equals to 135, right? So this means that, okay, the phase margin is good, that means the system is stable. Now let's say the phase margin is equals to 90 degree, minus 90 degree, minus. So then the phase margin will become how much? 180 minus 90, minus 90. So now the phase margin is 90 degree. So this is one system and this is another system. Which system is more stable? One the system having phase margin equals to 135 degree. Okay, at this point the at phase equals to, when the phase equals to 45 degree, the gain was 1, the gain was 1 for 45 degree. And after that the gain becomes below minus 1, below 1, not minus 1, below 1.
And nine minus 90 degree. What are those?
Huh?
Means at minus 90 degree.
Yes.
What is the is case? I'm not understanding that
Okay,
why.
so when a
Uh,
system, see, when a system has only one pole, okay, when the system has only one pole, it, right, like let's say that gs is equals to 10 upon s, 10 upon s, let's say s plus 10, s plus 5, let's say. What does this mean? This means that the phase is equals to how much? Minus tan inverse upon 5, right? Our system is has a Bode plot something like this. We have to find out log omega for here. So of log 5 minus 20 degrees. So this means that the phase will, as maximum it can go till how much? It can go till 90 degrees. That's it. So something like this. At log of 5. No, sorry, not like this. One second. One second. This is a phase curve. So something like this. So it can go till minus 90 degrees. So the system becomes unstable when it goes below minus 180 degree. So when the phase goes below minus 180 degree, then it is said that it's a unstable system. So this system 10 upon s plus 5 will always be stable. Okay.
yes, ma'am.
So what is your doubt?
My doubt is that minus 90 degree or minus 45 degree,
Haha.
uh, which which condition is more stable? Minus 90 degree, right?
5 minus 90.
Because um, minus 90. Mm, Oh, for this case, phase margin will be less. Okay, okay.
Hmm.
Hmm.
Okay.
Okay, ma'am. Understood.
Yeah, very good. So where we were trying to find out the phase margin. So try to find out the phase margin for this question, and then we'll move ahead.
69.5 degree.
69.5. Okay. Yes. Good. So here 69.5 degrees. Oh, sorry. So here 69.5 degrees is the correct answer. So how to find out? Yeah. So as I have already told you, for to find out phase margin, you have to do 180-degree plus phase of the system at omega is equals to omega g. This omega g is gain crossover frequency. Gain crossover frequency. I'm writing it as GCF. So yeah. So now let's try to find out the phase first. So the phase will be 0 degree minus 90 degree minus tan inverse omega by 5. This is actually like this angle of g j omega and h j omega. Okay, now since h here is equals to 1, so that for that we have a 0 degree phase, and since one pole is at 0 degree, so that is minus 90, and another is minus tan inverse omega by 5. Okay, so the value of omega will be minus 90 minus tan inverse omega by 5. For this omega, we have to put omega g, which is equals to how much? It is equals to it is equals to 1.87 radian per second. So we'll put 1.87 radian per second divided by 5. We got 0.37 and minus 90 minus tan inverse 0.37. So here the value of phase is minus 110.5 degree. So phase margin will become 180 plus 5, that is 180 minus 110.5, that is 69.5 degrees. Okay.
One more question.
Hmm.
In the exam, is that 10 inverse 1.87 divided by 5, that value means how we will means, there will be available for calculators or means even.
Most probably you will be given with either virtual scientific calculator, or you have to take your scientific calculator with you.
Okay.
Okay. So let's
In
go.
virtual, the virtual calculator, this will be possible. Then 10 inverse.
Yes, it will be possible. Yes.
Okay. Okay.
Hmm. So now, yeah, so as I told you, here the phase margin was 69.5 degree. Okay. So as there was one doubt of your, right? So similarly, now let's see if the phase margin changed to 80 degrees, right? It has increased from 69.5 to 80 degrees for the system. What will be the new gain crossover frequency? Understood? Here the question says that the phase margin is 180-degree. Now for this phase margin, what will be the new gain crossover frequency? So how to solve this question? See, we already know the phase margin is equals to 180-degree plus 5, right? 180-degree plus 5 at omega is equals to new omega. Omega, let's assume new omega to be omega dash j. So phase margin is 80-degree. Accordingly, we'll find the new phase of the system, and for that phase of the system we have to find out the omega dash g. Got it? How to solve this question?
Yes, ma'am.
Okay, so try to solve this one and then we'll discuss about it. I'm giving you 2 minutes.
0.88.
Okay, so let's discuss the solution for this question now. So yeah, so the phase margin here has become 80 degree. Okay, this means now one thing is when phase margin was 69.5 degree, compared to that when phase margin becomes 80 degree, the system becomes more stable. Okay, so now let's try to find out the phase. So we'll put 80 degrees equals to 180 degree plus 5. So 5 will be minus 100 degree. For this minus 100 degree, we'll put it in this equation, right? Which is the equation for the to find out the phase of the system. That is minus 90 degree minus tan inverse omega by 5. So from here we got the value of omega, which is 0.88 radian per second. So earlier the omega g was minus sorry 1.87 radian per second. Here omega is 0.88 radian per second. So gain crossover frequency will become 0.88 radian per second. Okay. Any doubt till here? So our gain crossover.
Um,
Huh.
Here, gain crossover frequency is reduced.
Huh, huh.
So,
Yes.
so what is the graphical representation?
Something like this. See, earlier it was like this. Now it is this. This is the new omega dash g. Earlier it was this. Okay.
So, gain will be reduced.
Okay. Gain for the negative feedback system. No, gain won't be reduced, but the for here, yeah, we can say that. Um, 1 second. Yeah, the overall gain will reduce. So for the
Oh,
system,
okay.
yeah,
Closed loop.
yeah, it's a closed loop, right? So overall the
Uh,
gain will reduce, right? Yeah. So is the question here? Let's go and solve for your doubt. Let's try to solve next question, and then your doubt will be. We can easily understand the whatever you have the doubt. We will easily be able to clear that out. Okay. So here for the new gain crossover frequency, what should be the gain of the negative feedback system? So if it is said that the system is has the same unity feedback, then also we could have found out the gain, right? But here it is asking to find out the gain for the unity feedback. Understood?
Yes.
Okay, so try to solve this question and then we'll discuss it.
Ma'am, what is the transfer function? Can you show once more?
Okay, wait, I'm
Okay, ma'am.
okay.
Ma'am, 0.446.
Okay, yeah, correct. So yes, so answer is 0.45 here, rounding 0.44. So here we have already got the gain crossover frequency, which is equals to 0.88 radian per second. Now for this gain crossover frequency, we know that the total gain will be equals to 1. Now we'll put it in the transfer function, right, to find out. And now since it is given that the feedback has a gain which is not equals to 1 anymore, so we'll try to find out that for omega is equals to omega g, which is now equals to 0.88 radian per second. We'll put the value here and we'll get the value of negative feedback, which is equals to 0.45. The gain for negative feedback is now equals to 0.545, right? It's a simple arithmetic equation from here. So let's go ahead and try to find out the relationship between gain crossover frequency omega gc and phase crossover frequency for a stable system. So first thing that you have to understand is the system is stable. Now for the stable system you have to find out the gain crossover frequency and phase crossover frequency. I'm giving you 2 minutes to solve this question. Sorry, I'm giving you 2 minutes to solve this question and then we'll discuss.
Ma'am, it would be option B.
Option D. Which one?
Ma'am, B, B.
B. Okay. Yeah, correct option. Why do you think so? It's okay if you are wrong. It doesn't matter if you're wrong or right. Tell me what you're thinking. Okay. All right. Okay. So see, it is said that the system is stable, right? So system is either have two poles, maximum of two poles, and it can have zero pole, one pole, two pole, since it's a stable system, right? So if the system is stable already, it is said that it's a stable system, that means that the phase of the system will maximum at infinity, it will go till how much? It will go till minus 180 degrees. So the omega crossover frequency, which is omega pc, which is the crossover frequency, will be uh, will be how much? Infinity or less than infinity. But since the system is stable, it will be uh, it will be okay it will be more than omega gc, right? Since see, omega gc means, right, let's say this is a one pole system, this is minus 20 dB, okay, and this is 0, which is 0, which means is 0 in dB,
Ma'am,
right?
you are not audible.
Oh, oh, so sorry. Okay, so all right, we'll go again. Sorry, so I was asking, okay, before solving this question, I was asking from you uh, how you thought that omega gc is will be less than omega pc.
Because ma'am, sometimes ago you told that for the phase crossover frequency
Hmm.
means like that example 1 by is plus 5. So phase crossover frequency 180 degree, it will not cross.
Hmm.
So then the system will be unstable. So for the 180 degree frequency, that means omega, that phase crossover frequency, it will become infinity.
Hmm. Right.
So,
Right. Yes, exactly. So this is here, the system is stable, right? The system is stable. So we know that the if the system is stable, it can be either it maximum it can go is still two pole system it can have, or it can have one pole or two pole or no pole. So the system is stable basically. So maximum it can go is still minus 180 degrees. So for minus 180 degree, there will be a asymptote at 180 degree, and that will be, it will meet at infinity. So omega pc will be infinity, whereas omega gc, if we see the Bode plot of this, will be whenever it becomes 0, this is omega gc, right? So
always finite.
if a system, let's say k by s plus 10, let's say this is the system, right? Then log of omega gc, it's a log of, this is a Bode plot, right? Log of omega gc is how much? Here it's a 20 log omega, no sorry, log omega gc, which is equals to 10, yeah, log of omega gc will be log 10, which is equals to 1. So this is 1, and here it's a 20 log k, t log k, and this is minus 20 dB per second. minus 20 dB per decade, not per second, sorry, per decade, right? So yeah, so
Ma'am, here I am not understanding the decade part. Means what does it mean?
it's a unit for a Bode plot.
Oh, okay, okay. Means dB I understand,
Huh.
but dB per decade.
Yeah, so that is how we represent Bode plot. Have you read Bode plot?
Still I have not read, but
Yeah, so uh, per decade is for, see, now it's a slope, right? So log omega gc here, and this is also in log terms. So this is in log terms, this is per decade, matlab per decade is how much? 10, right? So this is like 10, it is 10. So per decade basically means per that variable which has a log of base 10.
okay,
Okay, so here
okay,
log base 10 of omega.
mhm,
Okay.
okay,
So here this will be omega gc. So for omega gc, log of omega gc equals to 1, and this is 0. In terms of mod k, it will be equals to mod g, it will be equals to 1, right? So omega gc for this system will be something, but for this system, phase crossover, that is omega pc, will be how much? This is minus 90. Yeah, sorry. So it will never reach, it's a minus 90 degree, and it will never reach minus 180 degrees. So omega pc will be how much? Infinity, whereas omega gc will be something. So for a stable system, omega gc will always be less than omega pc. Okay.
okay, okay, ma'am.
Okay. So now let's try to solve next question. Here you are designing a butterworth filter with these specifications. Omega p is equals to 30k radian per second. Omega s is equals to 90k radian per second. Maximum amplitude is 5 dB. Minimum amplitude is 27 dB, and DC gain is 6 dB. What will be the order of this filter? So here you are designing a butterworth filter with these specifications. Okay. The first question is asked, what will be the order of this filter? Find out the order of this filter. No, sorry, not order. Find what will be the epsilon of this system, of this filter. So you have to find out E. Okay, I'm giving you 4 minutes. Try to solve this question, and then we'll discuss.
Ma'am, 1.47.
1.47. Okay, we'll wait for 2 more minutes and then we'll discuss. We will wait for 2 more minutes and then we'll discuss. Okay.
Okay, ma'am.
Let's try to solve this question then. So omega p is given as 30k per radian, 30k radian per second. Omega s is given as 90k radian per second. A max is 5 dB, A min is 27 dB. So it you must we okay, and DC attenuation is 6 dB. So for DC attenuation is equals to 5. Okay, so DC attenuation is 5 or 6. Okay, here it's 6, but in question it's a 5 dB. Okay, so there is a little mismatch. Anyways, for DC attenuation is equal to 5 dB. The formula is something like this. Okay, that is for this is for Butterworth filter. So if you would have gone through the classes given by the professor, you would know that this is the formula for Butterworth filter. Here it's a 20 log k divided by under root of 1 plus epsilon square omega, not omega p, omega by omega p. Okay, and for omega is equals to omega p, it will be 20 log k minus DC attenuation, which is equals to 5. So 20 log k minus 10 log. So from here it's a arithmetic calculation, that is 20 log k minus 10 log 1 plus epsilon square, which is equals to 20 log k minus 5. So 10 log 1 plus epsilon square is equals to 5. 1 plus epsilon square is equals to 10 to the power 10 is gone here, that is 10 to the power zero point 0.5, right? That is 5 by 10 and then log is gone. Okay, so epsilon square is equals to 1.469 equivalent to 1.447. Okay, any doubt here?
No, ma'am.
Okay, so let's try to solve another question. What will be the order of this filter? So from the same equation, you know the formula. Now you have to find out n. Okay, you have to find out n. So put you already know all the values. You know omega p, omega s, a max, a min, DC gain, and everything. You know the formula of the Butterworth filter. Try to solve this question for n. You already know the value of epsilon as well.
What is the value of omega p?
Yeah, here.
Okay, 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 ma'am.
Oh,
M3.
okay. Very good. So let's discuss solution. So we have to find out n is equals to, we know already the value of omega s, omega p, we know the value of epsilon square. So 20 log k upon under root 1 plus epsilon square omega s, omega p, 2n is equals to 20 log k minus 27. Yeah, that is a min we have put here. Okay, so this was a max. uh, this is not DC gain here, DC attenuation, this is a max. Okay, we know a max. Okay, so this is that, not the DC gain. For DC, for a min, yeah, so a max, for a max we have omega p, omega here, omega is equals to omega p. For a min value we have omega is equals to omega s. So here for omega s we will putting o a min, which is minus 27 sorry, 27 dB. So yeah, so we already know omega s, omega p, we know 20 log k minus a min, we know all the other values, we'll put it, we know the value of epsilon as well, we'll put it, and we got n is equals to 3. Okay, any doubt here?
No, ma'am.
Okay, so this is, so as I already discussed, we have to, since everything was given in the formula and all the other variables were given in the question, and epsilon we found in previous question, so we'll put it and we'll get the value of uh, the integer, the or n, which is equals to greatest integer, which is the order of the filter, which is equals to 3. So any doubt, any doubt, Shubham?
No, ma'am.
Okay, okay, so
Ma'am, what did I means where from where did I get the previous class notes or something?
acha, so what notes are you talking about?
Means notes means this class recording or
Okay, so this class recording you can get from the YouTube. So I have recorded it, and I will, for the for previous sessions also I have recorded and put it on my YouTube, and for this also I will put it on YouTube. So I'm giving you the link of my YouTube channel. From there you can take a look. Okay, from there you can access all the previous sessions, as well as you can find like these documents that I'm sharing with you. These documents also I will share the link of the Google Drive where I have uploaded all the documents. So that also I will share on the YouTube. In that the description of the video will have the Google Drive link, and from there you can get the documents. Okay,
okay, ma'am.
okay, so I'm going to share my video. Okay, so this is the link of previous session. This is for assignment 4. All right. Okay, so now I'm going to end this session. So all the best for assignment 5. And do you still have any doubt?
No, ma'am.
Okay, all right. Then all the best for assignment 5, and bye bye.
Ma'am, assignment 5 or means already date is over.
Okay, okay. So yeah, then all the best for assignment 6. Sorry.
Okay, ma'am.